Here we have another example of how we will be asked to use differentials to approximate our change in y. So what we want to do is go through the steps just as we did before. And here it says use the differential to approximate the change in y when x changes as indicated. So you're going to see problems like this again in your homework. So what we want to do first is go through the same procedure and take the derivative. So we'll rewrite this first. Y is equal to the quantity of x squared plus 8 to the 1/2 power. So we're going to take the derivative. dy dx is equal to 1/2 times the quantity of x squared plus 8 to the negative 1/2 times the derivative of the inside. So this is the chain rule. So what I want to do is just simplify this just slightly, as well as multiply by dx, because I need to get my change in x, which is dx, so I can solve for dy. So we have dy is equal to, when I multiply, these 2's will reduce, and I'm left with an x on the top, over, this drops to the bottom, to the 1/2 power, and multiply by dx. Okay, so this is my differential right here. This is what I want to use to approximate the value of dy. So the only thing that I really need to know is what is my x value and what is dx, meaning the change in x. Okay, so x is actually going to be 1 because x is changing from 1 to 0.97, meaning the value is getting smaller. So here, dx is equal to where I end minus where I started. So this is negative 0.03. So dy is equal to where I was times the change. Okay, so now I have 1 over, this is 9, the square root of 9 is 3, times negative 0.03. So dy is approximately negative 0.01, which is my change in y.